Alrighty, we survived that massive chunk of array methods. Hopefully, we all survived it. Now we're going to address this third bullet point here, just one video, but a very important topic, the idea of reference types in JavaScript. So you'll have to bear with me here for a moment. We're going to take a step back to strings or numbers. Any of the primitive types we saw earlier, strings, numbers, booleans, null, undefined, all those, they work differently than things like arrays and objects, which we're about to cover. So let's take a look at an example here of a single string. Let's go with fruit equals orange. Suppose we have this example string variable called fruit, and I make another variable called color. So I'll do let color equals fruit. I want it to have the exact same value. So fruit is storing the value of orange. Color is also storing the value of orange. If we look at color, it's orange, fruit is orange. Okay, and now what if I decide to change fruit? Fruit is now going to be watermelon. What is the value of color? We know fruit is watermelon. What is color? It's orange. So that hopefully makes sense. We're storing a value in a variable. So at the beginning, color is set to the same value, orange, but then we change the value in fruit, but that doesn't change the value in color. They're not linked. That's because they are primitive types, and when we work with primitive types, when we create a variable to store one, we're creating a value type variable. What that means is that in memory, JavaScript stores all of these variables. Every single variable we ever make is stored in memory. And when we're working with a value type variable, the actual value is stored in memory. So imagine every time we make a variable, there's a little slot in memory that's made to store your information for that variable. If you use a primitive type as the value, that value itself is stored. That is the thing that is put in the container, in the jar. But for large things like arrays, that doesn't work. Arrays can have tons of information in them. So instead of storing all of those values in the variable itself, what JavaScript does instead is it stores a reference to that array. And you can think of that reference as kind of like just a string of numbers, a memory address. We're not able to see it. There's not an easy way to get JavaScript to print it. But the key distinction here is that when we work with arrays and we put them in a variable, the variable itself does not hold the array. It holds an arrow, a pointer, a reference to where the array is in memory, compared to a value type variable where the actual value is stored. So we can see this in action if we do something like this. We'll just do nums equals 5, 6, 7, 8, and I'll make a second variable. We'll call this other nums equals nums. All right, so when we set up nums equals 5, 6, 7, 8, that array is not stored in the space in memory for nums. It's not stored in that jar. Instead, a reference to this array is stored. So you can kind of think of it as nums equals some reference in memory. Then when I say other nums equals nums, it will set other nums to be the same reference. So they're both pointing to the same thing in memory. Instead of each version or each variable storing the actual value of the array, they both are just pointing to the same thing. And that means if I change nums.push, let's go with 10. No, I guess 9 is next. And then we look at other nums. It reflects that change because updating nums doesn't change the value stored in nums. It is using this reference to find that array, update that array, but the reference is still the same. And other nums is looking for the exact same label or the same reference in memory. So when I change one, the other changes as well. So if we did other nums.pop, let's do it 2 times or maybe 3 times. And then we look at nums, it's also impacted. So this is a really important distinction. When you work with arrays, and we'll shortly see objects behave the same way, they are stored as reference types in variables or in memory rather than the actual value being stored. And that does have some important repercussions, one of which we'll address in the very next video about const, another way of making a variable that hasn't seemed all that useful to us right now. Okay, so I'll stop here. This is not the last time we'll talk about reference types, but I just wanted to introduce the idea. To sum it up in 5 seconds, primitive types are stored as the actual value in a variable. Arrays are different Instead, the variable stores a reference to where that array is in memory.